In this lesson, we're going to look at how to multiply rational expressions. And we've already talked about how to simplify rational expressions. And so what we're about to find out is that this is really no different at all. I know when you see the word multiply, you probably start to think about a lot of distributing and combining of like terms. But really, these are the same steps that we used when we were simplifying. We are simply going to factor all of the things that we can factor. We're going to figure out what numbers have to be left out of the domain. Then we're going to cancel any factors that are the same in the top and the bottom. And there's no need to multiply the factors back together when we're finished, so that's really good news. This makes our job of multiplying really easy. Let's multiply x minus 7 over x minus 1 times x squared minus 1 over 3x minus 21. And we just take each piece one at a time. The top left is x minus 7. That cannot be factored. The bottom left is x minus 1. That cannot be factored either. The top right is x squared minus 1. So that's a difference of squares, and that will factor into x minus 1 times x plus 1. The bottom right is 3x minus 21, so that has a common factor of 3. And that will leave x minus 7 in the parentheses. Now let's take each factor of the denominator one at a time and figure out what has to be left out of the domain. For x minus 1, we can't let x minus 1 equal 0, so that means x cannot equal 1. The 3 does not have a variable with it, so this 3 factor is all by itself, and therefore, since there's no variable, there's no effect on the domain. Any constant factors in the denominator you can just totally disregard when you're thinking about the domain. And then this x minus 7, we can't let that equal 0. That means that x cannot equal 0. Alright, so let's keep going now. I see an x minus 1 top and bottom. Well, an x minus 7 top and bottom. Also x minus 1. Alright, so I had a little, had the wrong factor marked out here, but I've got it fixed. X minus 1s need to be crossed out, and that leaves an x plus 1 in the top, and a 3 in the denominator. And of course we've still got our exclusions here. The domain cannot include 1 or 7. Alright, got a couple of other examples here to look at. We've got x plus 3 over x squared minus 4 times x squared minus x minus 6 over x squared plus 6x plus 9. Now, the top left cannot be factored, so that's simply x plus 3. The bottom left is a difference of squares, so that's going to make x minus 2 times x plus 2. The top right is a trinomial, so that's going to make two binomials. First times first is x times x. The signs need to be different. And last times last needs to be 3 times 2, and let's let the 3 be negative and the 2 be positive. So now check it out, that if we do outer plus inner, they're going to add up to negative 1x, and they do. Now the bottom right is a trinomial, so first times first needs to be x times x. The signs need to both be the same, and they need to both be positive. And then if last times last is 9, let's try 3 times 3. And now check out that outer plus inner is going to add up to 6x, so of course it does. Now, each of these factors in the denominator tells us something to leave out of the domain, except these two factors are the same. So, really, each of these two give us the same number to leave out. But let's start with the x minus 2. X minus 2 can't be 0. That means x can't be 2. Then x plus 2 can't be 0. That means x can't be negative 2. And then x plus 3 can't be 0. That means x can't be negative 3. And there's no need to do this one because they're exactly the same. Okay, so notice that we didn't mess with the top at all. The top has nothing to do with leaving numbers out of the domain. And now we can cancel. I see that we can cancel out an x plus 3. We can also cancel out an x plus 2. And that's all. Because now the x minus 3 on top is different from the x plus 3 in the bottom. So we're left with x minus 3 over x minus 2 times x plus 3. And we don't have to multiply these back together. We'll just leave them in factored form. And remember to note that x can't be 2 or negative 2 or negative 3. Alright, one more to do together. Let's multiply x cubed minus 8 over x squared minus 4 times x plus 2 over 3x. Now this top left is a difference of cubes. You remember difference of cubes? So remember that makes a binomial times a trinomial. So this is the cube of x and this is the cube of 2. So I'm going to put x minus 2 in the parentheses, and then in the trinomial parentheses we get x times x, and for the middle term we get plus 2x because it needs to be opposite sign from what we had here, and then x times 2 is 2x, and then the last is plus 4 because this is always positive, and then 2 times 2 goes here. The bottom left is a difference of squares, so that's going to make x minus 2 times x plus 2. The top right here will not factor, and the bottom right will not factor. So now let's see what we have to leave out of the domain. X minus 2 cannot equal 0. That means x can't be 2. X plus 2 can't be 0. That means x can't be negative 2. And then 3x can't be 0, so that means x cannot be 0. Or actually, I didn't need to copy the 3 here because remember I told you you could disregard a constant factor, so you could have just said x can't be 0 and been done with it. Alright, now we've got our numbers that have to be left out of the domain. Let's cancel out our x minus 2's and our x plus 2's, and that will leave us with x squared plus 2x plus 4 from here over 3x. And now notice that, I know some of you are going to look at those x's there and want to cancel them out, but remember 2x is a term of the top and we can never cancel terms. So the only way we could cancel this x is if we could factor an x from the entire top, but we cannot, so this one's finished. And we'll just note the numbers that have to be left out of the domain. And that's all there is to multiplying. It really doesn't feel much like multiplying at all. It's very much like simplifying.